Section 8-1, Part 1, Matching Linear Function Rules to Their Graphs. Describe each linear function using one of the following rules. So we need to pick from these equations which ones match these graphs. So let's first talk about the line y equals to x. Remember, a linear equation can be in the form of y equals mx plus b. You can also have a linear equation that just has a y equal to a number, like y equals to 6. You can also have a linear equation if you have just x equal to a number. Now, both the x and the y, if you have both of them in the same equation, they have to be raised to the first power. And of course, if they're the only variable, they have to be raised to the first power. If you have an exponent of 2, it is not a linear equation. If you have absolute value bars, it is not a linear equation. So you can see that all 1, 2, 3, 4, 5 of these have x and y. This one has both x and y, they're to the first power, that's a line. This one has both x and y to the first power, both x and y are to the first power, that's a line. These both are x and y to the first power, that's a line. X and y to the first power, that's a line. This one has just a y, but it's raised to the first power, so that's a line. If you have x equal to a number and it's just an x only, this is going to be a vertical line. And a vertical line goes up and down. So a vertical line looks like this, okay? Now, if you have just a y, that is a horizontal line. If you have just a y, that's a horizontal line, and it goes left to right. It is a horizontal line, and it goes left to right, okay? Now remember, if you have a line with a positive slope, it's slanting upward to the right. So a line that is slanting upward to the right has a positive slope. A line slanting downward to the right has a negative slope. Now, a horizontal line has a 0 slope, and a vertical line has an undefined slope. Okay? So a vertical line has an undefined slope. So that just gives you a little bit of information about what a linear equation looks like and their slopes. Okay? So, I don't see any vertical lines, therefore I know it's not going to be the one if it just has an X only. Of these 3 lines, I don't see a horizontal line, so I know it's not going to be one with just the Y only. So I know this equation is out. So it's either 1, 2, 3, or it's one of the first 4 for all 3 of these. I see this slope is negative. Remember, y equals mx plus b. M is your slope. If it's negative, that tells me my line is going downward. So really, this one is the only one that has a negative slope. Its slope is -1, so it must match b. So I'm going to say that y equals to -x is going to be this graph here. Now, we can check that out. So let's talk about graphing y equals to -x. So y equals to -x. All right. What I want us to start looking at is using a table. I'm going to use a table. We could use rise over run, okay? You've been doing that. Your y-intercept would be 0. You know, if you don't have a number added out here to the back, it is 0, okay? And your slope is -1 over +1, all right? So we would have a rise of -1, a run of +1. So we could graph this equation, and I'll just quickly graph it for us, okay? We know that my graph is passing through the origin, okay? And so if I'm at the origin, if I'm at 0, rise is -1, so I go down 1, running is positive 1, go to the right 1. And I could do that again because slope is constant all the way down the line. Go down 1 to the right 1. So you see, here is the line, okay? So that's how you've been graphing it using rise over run. And you see that does look exactly like B that I have here. Down 1 to the right 1. Down 1 to the right 1. So yes, y equals to negative x is B. Now, I want us to start being able to use a T-chart to graph a line also. Okay, I want us to be able to plug in numbers for x and get back the y values of each x value that forms an ordered pair, okay? So I'm going to pick my x's. I'm just going to pick 0, 1, and 2. Now, by me picking these points, I will plug them in one at a time into this equation. Remember, my equation was just y equals to negative x. Now, that's like negative 1. So if I plug in 0 into x in this equation, I have y equals to negative 1 times 0. Well, what is negative 1 times 0? That's 0. Therefore, when x is 0, y is 0. So I'm going to plug in y is 0. That's this point right here. It's the same point on the line that I graphed earlier when I used the y-intercept. Okay, let's plug in positive 1 into the equation. Y equals to negative 1 times positive 1 in for x. I'm plugging in positive 1 in for x. So negative 1 times 1 gives you negative 1. So when x was positive 1, y was negative 1. Notice there's the same point. Positive 1, down 1. That's the same point right here. There's my point 1, negative 1. This was my point 0, 0. All right, let's find another point on our graph. Plugging in x is 2. I have y equals to negative 1 times 2. Well, negative 1 times 2 is negative 2. So when x is 2, y is negative 2. So here's another point. To the right 2 and down 2. There's the other point 2, negative 2. So this is also another way to graph a line, is to pick x values, plug them in one at a time, and get back the y values, okay? So that's one way, another way of graphing a line. All right, so we know that, going back to my graphs, we know that B is y equals to negative x. Okay, I know it's not y equals to 2. I know neither one of these are y equals to 2. So I need to begin looking at these 3. These are the 3 that I have left, okay? So let's graph y equals to x. Let's graph it, y equals to x. So I'm going to graph y equals to x. I'm going to use a table. I'm going to pick 0, 1, and 2, okay? Now remember, there's a number in front of y, right? And being that I don't have a y-intercept, it's 0. So if I was to quickly graph this, let's find some points, plugging them in one at a time. I have y equals 2. I'm going to plug them in over here to the side. Plugging in 0 in for x. Y equals to 1 times 0. Well, 1 times 0 gives you 0. Therefore, y is 0. Plugging in 1 in for x. You have y equals to 1 times 1. Well, 1 times 1 gives you 1. All right, so I'm going to put 1 in for y. Plugging in 2 in for x. I have y equals to 1 times 2. Well, what is 1 times 2? 2. Therefore, when x was 2 and I plugged it in, I found y to be 2. So if I plot these points, 0, 0, 1, 1, and 2, 2, there is this line, okay? It has a positive slope of 1 slanting upward to the right. Now remember, I'm the one picking the x's. I'm the one picking the x's, and I could find more points. And I could pick other x values. If I picked other x values, it would still be points on this same line. So let's look back at our choices. Are either one of these, A or C, do they look like the line that I've just graphed? Slanting upward to the right, passing through the origin, 1, 1, 2, 2. We're rising 1, running 1. So let's look at a part. Pass it through the origin. Rise 1, run 1. There's 0.11. There's 0.22. Therefore, this equation is A. So this equation is y equals to x. We already know that this equation was y equals to negative x. Now let's find what C is, okay? Now, between these two, I can already tell you which one is C. This graph passes through the origin. Therefore, my y-intercept would be 0. What is the y-intercept of this graph? Y equals 2x. Doesn't it have plus 0 out here? So this one has a y-intercept of 0. Therefore, this one has got to be C, because what is the y-intercept of this graph? 2. And so this one does not pass through 2. It passes through the origin. Therefore, y equals to 2x has to be C. But let's graph it. Y equals to 2x. So I'm going to graph the line y equals to 2x. So I'm going to make my table or my T-chart. I'm going to pick 0, 1, and 2. My slope is 2. Just going back over what you've done previously. Your slope is 2. It's 2 over 1. Your y-intercept is 0. And you can also graph this line by using rise over run. But I'm just introducing you to a table and plugging in numbers, picking x's and plugging them in one at a time to get back your y value. So let's plug into the equation y equals to 2x, plugging in 0. I have y equals to 2 times 0. 2 times 0 gives you 0. Therefore, I plug in y is 0. Therefore, I know my graph is passing through the origin. Now let's plug in x is 1. Y equals to 2 times 1. 2 times 1 gives you 2. Therefore, when x is 1, y is 2. So let's plot the point 1 up 2. There's that point. This point is 1, 2. To the right 1, up 2. Now let's plug in 2 into my equation. 2 times x is 2. What is 2 times 2? 4. So when I plugged in x is 2, I got my y to be 4. I'm forming ordered pairs. These are ordered pairs is what I'm forming. So if I plot the point 2, up 1, 2, 3, 4, there's that point. There's my line. Does that look like C? So going to C, does that look like C? Does it pass through the origin? All right. Are we rising 1, 2 and running 1? Do we have the point 1, 2? Yes. Okay. So this is y equals to x. Y equals to 2x. The name of this graph is y equals to 2x. Y equals to 2x is C. So there was my equation, y equals to 2x.